So the second part of this question is only a 1 marker, but I'm going to go through how you do it from first principles, okay? Because I think it's important. Plus, I like half equations. Who doesn't? Right, so we are combining equation 1. And remember, for electrochemistry, the convention we use is that these are always going to be quoted as reduction potentials, okay? And I'm not going to put the state symbols, but the electrode potential, or the reduction potential here is minus 0.74 volts. Okay. Then equation number 2 is reaction number 4, and reaction number 4 is this. And we're forming Mn2 plus 4H2O. I'm trying to get it in shot. And the reduction potential is plus 1.51 volts. I don't know why that number is in my head. Right, what's going on? Well, have a look at the most negative electrode potential to start with, okay? And that's the one of chromium. And the sign here is telling you the position of the equilibrium, okay? So the fact that this is a negative value, this is telling you that if you have chromium solid and a solution of chromium 3+, the position is not over to the right. So chromium 3+ doesn't want to accept the electrons and form chromium. Now what actually wants to happen is that the chromium solid is releasing electrons, hence the negative reduction potential, okay? So this equilibrium lies way over to the left-hand side. Okay? So we've got a lot of chromium 3+ in solution and 3 electrons forming on the surface of the chromium. Okay. Consequently, what's going on in reaction number 2 is the opposite. Have a look at this sign. It's plus 1.51. That's a really, really strong oxidizing agent going from left to right. Okay, and what's happening here is the MnO4- is taking electrons and forming Mn2+. Chromium, on the other hand, just going back to it, is doing the opposite. So chromium is a good reducing agent, MnO4- is a good oxidizing agent, and let's have a look at the cell potentials when we connect these together and the full equation, okay? Now, if some of you might not have seen this before, but this is called the anti-clockwise rule. You put the most negative reduction potential at the top, the most positive one at the bottom, and the most negative electrode potential goes from right to left. As you can see, releasing electrons, the more positive one is going to accept those electrons and form whatever it forms, okay? So this is called the anti-clockwise rule, because that thing gets oxidized and this thing gets reduced, okay? So it's really important knowing what's happening in terms of oxidation and reduction, because that's fundamentally what's going on. So what I'm going to do is rewrite 1, but as an oxidation reaction. So I'm going to call this 1A. So chromium is going to this. And by the way, for the oxidation, this is actually going to be flipped, right? This is going to be plus 0.74 volts. And 2A is going in the reduction reaction, so that's going to be what it was before. And the reduction potential is plus 1.51 volts. Cool. I'll just put boxes around these guys, okay? I'm actually going to get rid of that because I need a bit of space. So, to make a full equation, there is a problem with what we've got so far. The problem is this. The chromium is giving out 3 electrons, but the manganate ion is accepting 5, and we need equal numbers of electrons here. So what we're going to do is multiply the top one by 5, and we're going to multiply the bottom one by 3, okay? And if we do that, we are going to get 5 lots of chromium, 5 lots of Cr3 plus 15 electrons. Okay, and if we do this for the bottom one and multiply everything by 3, that's going to be a 3 there. You're going to have 24H plus. You're going to have 15 electrons. You're going to have 3Mn2 plus. And you're going to have 12H2O. All right, cool. So if you add these up now, so if you add, let's just call this equation 3 and equation 4. If you add up 3 and 4, The electrons are going to cancel out. Are there any other like terms to cancel out? I don't think there are. So once we add these guys up, let's see what we get. So everything on the left of the arrow is going to be your reactants. So this is going to be 5Cr plus 3 MnO4 minus plus 24H plus. The electrons are not going to be included here. 5Cr3 plus 3 Mn2 plus 12 H2O. Smiley face, all for 1 mark. Ta-ta. If you're enjoying this content, please subscribe to my channel and click the link in my description to sign up to my course.